Chances are, if you ask someone to picture a city, the first thing that will come up in their head is a foggy picture of a large and noisy town, with ghostly skylines and traffic jams everywhere. This fogginess, specifically, is due to air pollutions. Air pollutions occur due to the introduction of harmful pollutants such as gases, particulates, and other forms of microbes. Air pollutants usually come from smokestacks of factories or exhaust fumes from cars or buses. However, new sources of air pollutants will arise, not from below, but from above, specifically the planes that fly high above in the skies. Aircraft emissions generally consist of CO2 by about 70%, while the rest are nitrous gases, water vapor, ozone, and other forms of fine particulate matter such as soot. It is well known that the CO2 is an extremely potent greenhouse gas. The gases emitted from an aircraft present medical issues as well. The fine particulate matters, dubbed PM2.5 as well as ozone, emitted by the plane may increase the risks of lung cancer and other respiratory diseases.
In the case of nitrous oxide, aviation only contributes a small proportion, about 3% of the total global nitrous oxide. The models show that aviation contributes a large fraction to the concentrations of nitrogen oxide in the upper troposphere. Nitrogen oxide gases play an important role in the formation of smog, producing the brown haze often observed over cities, particularly during summer. When exposed to the UV rays in sunlight, nitrogen oxide molecules break apart and form ozone. The problem is made worse by the presence of volatile organic compounds in the atmosphere, which also interact with nitrogen oxide to form dangerous molecules.
Gas emissions, be it from flights, factories, or other kind of source of pollution, surely impact the atmosphere. The effects can take three major forms, which are related to each other. Greenhouse gases are gases which have direct effect on the atmosphere. These gases trap heat inside Earth so it cannot escape to outer space. One of the most long-lasting gases is carbon dioxide, which can stay in the atmosphere for a century at minimum. Ozone production and depletion is also an effect. Ozone layer is a layer which absorbs sun radiation. Although not directly affected by carbon dioxide, it can deplete if exposed to CFC and HFC. This depletion, which happens mostly in the polar region, can be a contributing factor to climate change. Direct effect from flight are condensed trails, which are clouds formed by condensation of water vapor around aerosols from aircraft exhaust. These contrails tend to warm the Earth's surface from direct radiative forcing.
Is there any regulations on these emissions? Well, International Civil Aviation Organization, or ICAO, a branch of the United Nations that specializes in the establishment of standards and guidance on civil aviation, including the environment, through the Committee on Aviation Environmental Protection, or CAEP, achieved a significant milestone in 2016, designing the world's first carbon dioxide efficiency standard for aircraft, which makes carbon dioxide emissions a part of the certification process, following a long 6 years negotiation between the governments, environmental groups, and the industry, to ensure a stringency level that is both ambitious and realistic. The higher stringency level for both jet aircraft and propeller aircraft has been up and running for all new aircraft types since January 2020, and for all in-production aircraft models by 2028. The standard focuses on the cruise flight performance, which produces the most carbon dioxide emissions for each aircraft type and evaluated in maximum metric value, expressed in maximum specific range and reference geometric factor.
The next is technological solution on aircraft emissions. The first one is efficiency improvement. The key technologies include lightweight structure, highly efficient engines, and aerodynamic improvements to the body and wings. The second one is economic instrument, like carbon tax and emission trading system. These trade take advantage of market forces, thus finding the cheapest means of reducing emission. The third one is by searching alternative fuels. Algae, for example, provide opportunity for producing aviation biofuels that have potential to be low carbon. But the challenge is the fact that they are very expensive. And then electric or hybrid electric aircraft. Taken from Gita, a comprehensive review on energy management strategies of hybrid energy storage system for electric vehicles 2017 said that electric propulsion system can achieve zero emission locally, but it will still take time to achieve that for aircraft.